Alright, in this video we want to learn how to do something called writing a polynomial function when they give us these zeros, when they give us the solutions. And the goal, here's the main idea. I'll give you a super simple example here. Suppose I told you most of the time they will give us an equation and say find the solutions. So for example, they might say x plus 3 is equal to 0, solve that equation. And you would do that by subtracting 3 and you get x equals negative 3. In this example, what we want to do is start right here. We want to start with the equation and we want to wind up back here. We want to write the equation that has negative 3 as a solution. So here's an easy way to do that. Super simple example. Suppose I told you that a solution a solution of an equation is 4. I said write the equation that has a solution of 4. Well, you know there's going to be some equation. If it has a solution of 4, it means when I plug in 4, it's going to equal 0. That's what we mean when we say find the solution. So I'm going to have a variable x, and we will take 4 and plug it in right there. And the question is, what do I have to do to 4 to get 0? And the answer is minus 4. So that's what we're trying to do. That is our answer. We wrote an equation, and actually let's change that from 0. We'll make it f of x. Our equation, our function, f of x is equal to x minus 4. That's the function that has a 0 at positive 4. So we'll do two examples here, and one of them is easier than the other. We'll start with number 1. Number 1 says now we have 3 solutions, so we know if we do this correctly, our answer should have something with x to the 3rd power. So let's keep that in mind as we write this. Okay, and our goal again is to write a function that has these numbers as zeros right here. So f of x is equal to, and then I'm going to have 3 solutions. I'll make 3 parentheses here. Alright, so let's think about it. If I take negative 4 and I plug it in right here, what do I have to do to negative 4 to get 0? Because that's what it means to be a solution. It means what makes it equal 0. So if I put negative 4 there, I'd have to add 4 to get 0. So it's always x minus whatever your 0 is. In this case, you could have written this as x minus negative 4, which is the same as x plus 4. Okay, same thing. If I take 1 and I plug it right here for x, what do I have to do with 1 to get 0? I have to subtract. It's x minus 1. And then finally, our last value is negative 3. If we take negative 3 and plug it in, what would you have to do there? You have to add 3 to make 0. So this is our function. All we have to do to simplify this now is just multiply it out using FOIL. So x times x is x squared. This will be plus 4x. And then in outside terms is minus 1x, and then 4 minus 1 is negative 4. So we could simplify that to x squared plus 3x minus 4, and then we still have to multiply it by x plus 3. So x squared times x is x cubed. Then we're going to have x squared plus 3. That's going to be plus 3x squared, and then inside terms we'll have 3x plus another 3x would be plus 3x squared again, so these will combine to be plus 6x squared. It's kind of searching out the like terms before we write them. Okay, and then we have 3x plus 3, that's going to be 9x, and then minus 4 times x will be minus 4x, so that's going to give us 5x. And then finally we have, let me see if I can find a different color here, we have negative 4 times positive 3 would be negative 12, so this function should be our solution. If you take any one of those numbers and you plug it in right here for x, in each case you should get 0. Let's just double check that we did this correctly. We got x squared times x squared times 3, 3x times x, 3x times 3, negative 4 times x, negative 4 times 3, so that works. Alright, this next one is certainly more challenging, number 2, because they're imaginary zeros. So here's a couple things that we need to know. I'm going to move this over so you can see it. First thing we need to know is imaginary zeros always come in pairs, and you'll see why in just a sec. They always come in pairs, so you can't have 1 or 3 or 5. They have to be either no imaginary zeros, or 2 of them, or 4 of them, or 6 of them. And the question is, what kind of pairs do they come in? They always come in pairs, which are called conjugates. So you may remember this from an earlier unit, but if not, let's recall it. Conjugates work like this. Let's suppose I have 3 plus 2i. That's my imaginary number, my complex number. Actually, let me write that. It's called complex conjugates. Complex means a combination of real parts of the number like 3 and imaginary parts like 2i. So the conjugate of 3 plus I is 3 minus 2i. Okay, the conjugate of negative 1 plus 7i. Let me write a couple more here. I want you to try to pause the video and see if you can figure out what the conjugates are. So this one would be 3 minus 2i. Okay, the conjugate of negative 1 plus 7i is negative 1 minus 7i. And finally, the conjugate of 9 minus 2i is 9 plus 2i. So the only thing we're doing in every case is we're taking this middle value, or this middle sign, plus, and we're changing it to minus, or if it's minus, we're changing it to plus. We just reverse those. Okay, why do they come in conjugate pairs? That's kind of an interesting question. Here's why. If you multiply conjugates together, the i's will cancel each other out, and you'll be left with only real numbers. So let's just test that. Let's use these two conjugates right here. So 3 plus 2i times 3 minus 2i, and let's see what happens. So if we were to FOIL these out together, 3 times 3 is 9, 3 times negative 2i is minus 6i, 2i times 3 is plus 6i, and you can see those are going to cancel. And then 2i times negative 2i is negative 4i squared. I squared is a number, though. It equals negative 1. So negative 4 times negative 1 is positive 4 plus that 9, and that's equal to 13. So you can see when we multiply conjugates together, we get a real answer. That's why they come in conjugate pairs, because our actual function that we're going to write is only going to have real numbers in it. It won't have i's. Okay, so let's keep that in mind. The other thing I want you to keep in mind, and you'll see why again when we actually do this, is hopefully you recall from our factoring studies that something like that right there would factor. That's called a difference of squares. That would factor to x plus 5 times x minus 5. Okay, why is that important? Because when we do this problem, we're going to have to multiply, and this kind of looks the same up here. The pattern for difference of squares is something plus a number, and that same something minus that same number. So that's what's happening here. X plus 5, x minus 5. The only thing changing is the plus and the minus. So if we want a shortcut, if we wanted to multiply things that come out to be difference of squares, we can shortcut that by saying that's going to be x squared, because that's what x times x is, and then 8 times negative 8 is minus 64. That's kind of a shortcut way to multiply those. All right, with all that said, let's now write our function. And I can tell you right away this is going to have 4 zeros, because we said conjugates or imaginary zeros always come in pairs, and they always come in pairs that are conjugates. So the conjugate of negative 1 minus 2i is negative 1 plus 2i, and the conjugate of positive I is just negative I. So we know that we're going to have 4 zeros, and they're all imaginary. And so let's write our function right here. Okay, so f of x is going to be equal to, divide that off for a sec, it's going to be equal to 4 things multiplied together right here. Okay, and it's going to be these 4 zeros. So in all cases, we're going to have an x right here. And remember that it's always x minus the 0, so let's start with this one, x minus I, because if you took I and plugged it in there, I minus I would be 0. Okay, then we're going to have x minus that negative I, so that's the same as x plus I. And then these next ones are slightly more complicated to understand, so let's take this one right here. It's always x minus the 0, so we'll have x minus negative 1 minus 2i. Okay, why is that? Because if you put that in right there, if you put in negative 1 minus 2i and then you subtracted it from itself, again you would get 0. That's why we wrote it like that. And then finally this one right here, if I plug that in for x right here, I'd have to subtract it from itself. That would guarantee that I get 0. Alright, so that is actually our function. This thing right here, as messy as it looks, that's our function, but we don't want to leave it like that. We want to actually multiply it out so we can get a nicer looking answer here. So let's start with x minus I, x plus I, keeping in mind this shortcut right here that we mentioned, that when we have a difference of squares, this is our shortcut. When we have a difference of squares, we can easily FOIL those out. So x minus I times x plus I is going to be x squared minus I squared. The outside and inside terms will cancel. I squared is the same as negative 1, so x squared minus negative 1 is the same as x squared plus 1. So there at least is our first part. Okay, here's kind of the trick for this next part, because this, you could multiply this times this using FOIL, and that would work, but it would be kind of a mess. Here's kind of a shortcut for doing this. What I'm going to do is take this negative right here and distribute it inside. So minus negative 1 is like x plus 1, minus negative 2i is like plus 2i. Same thing here, minus negative 1 is like plus 1, minus 2i is just going to be minus 2i. Okay, why did we do this? Here's why. If you look at this carefully, it doesn't necessarily look like it right now, but this is actually the same pattern as up here. X plus 8, x minus 8. Let's rewrite it so we can see how. I'm going to put kind of brackets around this so you can see how this looks like. And everywhere I see an x plus 1, just so you can see this better, I'm going to replace that with a letter, and let's call that the letter A. We're just going to substitute wherever we see an x plus 1, because there's an x plus 1 in both of them. Let's replace it with the letter A. So this right here becomes A plus 2i, and this right here becomes A minus 2i. And again, you don't have to do it the way that we're doing it right here. I'm just showing you because I think it's easier to multiply A plus 2i times A minus 2i than it is to multiply this messy thing right here. Okay, now this looks like a difference of squares. It's something plus 2i, something minus 2i, so we can use that to our advantage. When we FOIL this out, remember that the pattern is A times A is A squared. Outside and inside terms will cancel, so we don't even have to worry about those. And then 2i times negative 2i will be minus 4i squared. Okay, now let's simplify this a little bit more. So remember that I squared is equal to negative 1. So this right here is the same as negative 1. So we have negative 4 times negative 1 will be positive 4. So let's write that as a squared plus 4. And then here's the only two things we have to do now. Remember that a was equal to this right here. So let's take our x plus 1 and substitute it back in at this point. That's a little bit easier to just see the pattern when we don't have that. Remember, this I should be writing equals f of x, because that's our function. All right, so now all we have to do is just simplify this some more at this point. So this is still going to be x squared plus 1. And when we FOIL this out, let's just do it over here. X plus 1 squared is equal to this. And this comes out to be x squared plus 1x plus another 1x plus 1. That's the same as x squared plus 2x plus 1. Okay, so then we have this coming out to be x squared plus 2x plus 1, and then we still have that plus 4 right there. So that's going to be x squared plus 1 times x squared plus 2x, and then 1 plus 4 equals 5. And now all we have to do is multiply this out, and that will be our final answer. So let's FOIL this out. So or I shouldn't say FOIL, because we actually have 5 terms here. FOIL only really works with 4 terms. So f of x equals, we have x squared times x squared is x to the 4th. X squared times 2x would be 2x cubed. X squared times 5 would be 5x squared. That takes care of our first part. Then we have 1 times x squared would be x squared. 1 times 2x is 2x. And finally, 1 times 5 is 5. And so our final answer is just the function that has those 4 zeros at the top would be x to the 4th plus 2x cubed plus these add to 6x squared. Okay, and then we have this part plus 2x plus 5. That right there is raised to the 4th power. So it should have 4 zeros, and it does. We ended up with two pairs of imaginary zeros, and that's how we would write that function.